So in this video, we'll be covering the material from 1.1 categorical data displays and analysis. So that you know what you're looking for, here's the objectives for this video. We're going to display categorical data with a bar graph. We're going to talk about whether a categorical data could be done with a bar graph, could also be done using a pie chart, and there's one condition we look for. We're going to identify what makes some graphs of categorical data deceptive, and that could be deceptive bar graphs or pie charts, and we just want to be on the lookout for that. We want to calculate and display the marginal distribution of a categorical variable from a two-way table. Now, we highlight marginal distribution because that might be a word that you're not familiar with, and it's something that you should be familiar with by the end of the day. Like, what do we mean when we say marginal? And two-way table, it's something you've experienced with, but again, that vocabulary just might not be something that you're used to using, so highlight that. We're going to calculate and display the conditional distribution of a categorical variable for a particular value of the other categorical variable. So that might start giving you an idea of what they mean by conditional distribution, or it might be too wordy to do that. So some examples will be available for you. And then finally, describe the association between two categorical variables by comparing appropriate conditional distributions. Now that sounds like a really challenging thing to do, it's pretty wordy, but it's something I think that people would do naturally if we put data in front of them. So let's figure out what that actually means by the end of this video. So we'll start with the bar chart. Bar chart is one great way to show categorical data, and a reminder that categorical data is data that you're not going to average or anything like that. It's putting individuals into a certain category. Now, it turns out this bar chart, which shows categories of ages, so from 12 to 17 age, from age 18 to 24, it makes the categories numeric, but just understand that we are kind of counting tick marks, how many people are in this group. So even though it's numerically described, it's not a quantitative variable. And then on the left-hand side, it might be hard to see here, your vertical axis, that's the number of people who owned an MP3 player. And I want to point out that those are frequencies, and in this case, they're just counts. So we want to keep an ear out for what do we mean by the difference between frequencies and relative frequencies. The frequencies are just counts. So the categories, when you do a bar graph, should be separated from each other. Even in this case, where 17 is a number that feels like it smoothly connects to 18. It's if you're doing categories, let everyone know their categories by putting spaces between the bars. Don't stack them directly side by side so they share an edge. And the next thing when you're drawing these things, make sure your bars have equal width. It may not be your intent, but it's very misleading if you use wider bars at different points. So let me try to illustrate that. Right now, you can see from this graph that it seems like from the data that was collected, 12 to 17-year-olds were the people who owned MP3 players more at this time when the data was collected. And then there was a tie between the next two categories. But if we used wider bars, this category 25 to 34, the area of it outweighs the area of 18 to 24, and that tricks people. So if you're trying to do a non-deceptive graph, you want to use equal widths. It's called the area principle. Another place where the area principle shows up a lot of times is pictographs, where if you're using drawings of buses and drawings of cars to keep track of how many tallies there were, how many counts there were, and you use a big bus because they're big and a small car because they're small, but each stand for two, that's pretty misleading too. So the area principle just says when you're presenting your data, make sure you're aware that the viewer's eye picks up area and assigns like weight to that. So you want to be careful. This is a pie chart. This could be used to represent categorical data. And right now this was for a Pokemon type, and again, a little outdated. But what we have here is water, electric, poison, ground. These are four categories, very specific descriptions, and then they have an other category. And that other is pretty important here because categories, when you use a pie chart, they need to be every single part of a whole. And there shouldn't be any overlap between them. So them throwing this category of other in there was a pretty wise move because now we know that this is 1/4 of all Pokemon, not just the ones that we decided to describe. This other takes care of all. So make sure your categories represent a whole and there's no overlap. So I wonder, looking at this bar chart over here, whether it would be appropriate to use a pie chart to display that categorical data that was represented in the bar chart. And when I ask a question, I usually ask for one where I think there could be incorrect answers out there because that's the best way to learn. So I hope that's a bit of a challenging question. I would ask you, if you are kind of following along live with me, that you would maybe use the yes or no buttons in the participant page. And let's see what you think. Would yes, it's okay to use a pie chart to do this bar graph information, or do you think it's a no? And you can make an argument for either case, I think. But I would probably fall on the no category. And it comes down to this. 12 to 17, okay. 18 to 24, yeah. So you have this nice, you've made sure you caught every single age there. And this 55 plus is a really nice attempt. But is it possible there's people from age 0 to 11 who own MP3 players at this point? Now, if you said, yes, it's okay to use a pie chart for this thing because every single person who could reasonably own one, you'd be making the argument, no one at age 11 owns anything, their parents own it. So I would probably take either answer, but I would ask you to kind of support your answer. But I would probably go with no because not every single age number is represented here. And there's no note telling me that I'm only talking about 12-year-olds now. Next thing we're going to look at is a side-by-side bar chart. That's another great way to show categorical data. And what it's doing is it's a little bit more complicated data at that point, more detailed out. So let's pretend that this bar chart is the way that members of a gym were asked how many times a week they used free weights as part of their workout. So the gym members they were able to get a hold of, they interviewed them, they asked them, could you please tell me whether you are male or female? And then also or tell me your gender, and the answers were male and female. And then also how many times per week do you use free weights? And this was the result that they got. So here we have relative frequencies. The fact that they use percentages over here, we don't know whether it was 1 person, 2 people, 3 people for each of these bars, but relative frequencies is another common thing. And I just want you to know that when they use the word relative, they are talking about percentages. So frequencies are counts, tick marks, and relative frequencies are percentages. I'm wondering when we look at this thing, what categories we think we might have. So again, that's a question where if we're live here, I'd like you to think about it and answer it in the chat and think about one of the categories that is represented in this side-by-side chart. Over here, the categories we had were age group, and I wonder what people think over here. I would imagine a very common answer is, so a category would be whether they never use free weights, whether they do it 1 to 2 times, whether they use 3 to 4 times. That would be someone who's just reading along the horizontal line. But someone who's thinking deeper might say, besides those 5 categories that describe usage, there's also 2 categories that describe gender. So this is the situation where there's 2 variables that are being tracked, gender and usage, and both are being represented by this side-by-side bar chart. So there's 2 variables displayed, there's 2 categories for gender, and there's 5 categories for usage. So a conditional distribution, we can start kind of scratching the surface on that. When you look at this graph, you can't help it. You notice differences between male and female in this group that were interviewed. I think that people probably look at this and think, well, that's at least notable, and that the females who were interviewed, that almost 48% of those interviewed had never used free weights. And that's much higher percentage than the percentage of males who didn't. So what you're doing at that point is you are analyzing the way that one variable, usage, one variable, gender, is being distributed over another variable, and that's going to be usage. We'll do more examples of this. But what we allow to do with a bar chart, what it's easier for us to do then is to compare how these kind of categories break out based on the other variable. So if we're making a comparison, we might say among the members we asked, a greater percentage of males used free weights 3 to 7 times per week than females did, these last 3 categories. The largest difference was seen in this 5 to 6. Someone else might make they might make the comparison I made earlier. But side-by-side bar charts, a great way to start taking a look at how one variable is distributed over the other. Another way we could represent that is a segmented bar graph. I don't think we have as much experience with this, but I just want you to see it. I think a lot of students could probably feel their way through this, kind of looking at the labels. But here what they've done is they made one bar to represent male and one to represent female. So the variable gender, the variable gender has 2 categories with it, and each of those categories is broken up into the 5 categories of the other variable. So to try to make this clearer, this bar on the side-by-side bar graph represents 31% of the males who said every day. And then that same 31% is represented up here, but it's seen as 100 to about 69% there. So this is the 31%. And so it's important that you use good, consistent spacing on your vertical axis so that you can make good comparisons. And that was a last little tip. The last thing I said there was a little tip on how you can graph well. Things you do when you graph poorly are you're inconsistent with the widths of the bars. I talked about that earlier. And then another one that can get you is if you don't use zero, sometimes you're trying to, kind of maybe feel like you don't need that much space. But if you looked at this graph and the graph doesn't start at zero for the vertical axis, someone who's kind of not looking closely could say, well, it looks like Android is about doubling up iPhone usage. And this area here is about twice as big as the area there. But if you look more closely, this is about 170 respondents, and this is about 210 respondents. So it's really only about a 25% increase from iPhone to Android, where someone might look like it's a full doubling, a full 100% increase. So a habit that you want to get out of is starting anywhere but zero. So, and get in the habit of using zero as your first label. So next objective we're going to try to do is to calculate and display marginal distributions of categorical variables in a two-way table. So let's talk about what a two-way table is. It's a way to record counts or relative frequency of two category variables at once. And remember, counts are going to be called frequency, and relative frequency is referring to percents. And here's a situation where there would be multiple variables, two categorical variables. In the United States and the United Kingdom, students aged 9 through 13 were asked which of the following superpower they would prefer. And then 5 superpowers were laid out to them. So a reasonable question right now, because we're saying two-way tables are a good way to work with two variables at once, would be what are the variables and what are the categories that are kind of suggested by that prompt? And you could answer that by saying we would categorize individuals using these two variables. And if you're brave enough, if you could unmute and answer yourself if you're working with me live here. So I would say that the two variables that we're using here are kind of country of origin. That's one variable that has two categories. And then also superpower, which superpower they're interested in is another variable. And there would be, it sounds like 5 categories for that. Let's look at more closely. There you go. Here's your information. Here's your actual data. Now, this idea of a marginal distribution, there's a lot of things you could do to try to describe this. And one thing you could do is you could lay out marginal distributions. So when I was first learning the material for the course in my earlier in my stat career, I looked at marginal and thought, how could I convince myself of what a marginal distribution is? Does it make sense? Does that title make sense? So margins, what do I know about margins? And margins are maybe sometimes differences, margins, or you could be on the margins of society, which are kind of these outer edges. Someone from who is studying business, a lot of times they talk about a margin being small, like there's a marginal difference, marginal growth. But it turns out it's even simpler than that. They mean the margin. Like if you have a page of paper and there's this blank space to one side or the other of the writing, that's the margin. And the indication there is if you are doing a marginal distribution, you're going to need totals. And this is a good place to put your totals in the margin. So if you were asked, find the marginal distribution of superpower preference, find the marginal distribution superpower preference, the word marginal needs to announce to us, so they want to know out of the grand total of all the students, regardless of where they came from, what percentage of them liked this superpower, what percentage of them liked this superpower. So you do need the totals in the margin, and most importantly, you need this total of all the sample. How many students are in the sample? 415, that's going to be key. So if we then had to find the marginal distribution for flight, we would say, well, that's 99 respondents out of the 415 total. But notice how we're pulling those numbers both from margins. If you show your work and you write 0.239, that's going to be perfectly acceptable. If you show your work and write 0.24, also acceptable. And if you put 24% and show no work, they don't give you credit on the AP test. You need to show your work and write 24%. So you can write it as a decimal or a percent. Rounding is really not an issue with AP graders, but showing your work is. So if you were going to do that for the next category for each time, you would show your work, and then you could, again, you have some flexibility on how you write your answer. But those are two pieces of the marginal distribution of superpower. If you start talking about conditional distribution, now this one I had an easier time with because, well, like let's read the questions. Find the conditional distributions of superpower preference among students from the United Kingdom and the United States. So we're looking for conditional distributions of superpower among students from the United States or the UK. So it feels like they're telling us we would like to think about the UK and talk about how the superpowers are distributed there. And then we have this other group here. And you're going to eventually start getting into this feel of like, well, what's the cause and what's the effect? It'll help you figure out which way you want to go with this. But at this point, we're going to need these totals, and we're not going to need this number at all. Because if we're doing how is the variable superpower spread over the United States, I'm going to start this for you, and then you guys are going to continue it in our classwork. So if we were doing for the US or the UK, we would have to find out, well, let's see, there's 54 who liked flight among the 200 for the UK. There were 45 who liked flight among the 215 for the US. So we would do 27% of the UK preferred flight, and then we would go, I guess, 45 divided by 215, that percentage of US preferred flight, and you would keep going from there. So as I said, we're going to move on to some classwork now. Your job is going to be to finish up the conditional distribution that I just started here. You might have some people in your group who want a little bit more clarity on the material here. And then you're also going to be asked to present it in a way that visually, that we could do a nice comparison to see if there's any association between, could we use your picture to figure out whether there's any connection or association between the UK and the US? Is there any patterns on students from one country having more of a preference of one of these superpowers? So that's going to be your job, and we'll have more clarity in the face-to-face instruction. We'll tell you what your directions are.